The sun is the most dominant object in our solar system. It accounts for more than 99% of the total mass of all planets, moons, asteroids, and everything else orbiting it. It holds everything together with its immense gravitational pull. But in the grand scale of the universe, our mighty sun is actually just an average star, one among hundreds of billions in our galaxy, the Milky Way, and among trillions more in the universe. Although it feels unique to us because it gives us life and light, it is in fact a rather ordinary player in the cosmic arena. The sun is classified as a G-type main sequence star or a yellow dwarf, and while that might sound large and intimidating in cosmic terms, it sits comfortably in the middle, not too big, not too small, not too bright, and not too dim, just average when compared to the wide variety of stars we've observed. One fascinating fact is how incredibly round the sun is. Its equatorial and polar diameters differ by only about 6 miles, that's roughly 10 kilometers, which is an astonishing level of symmetry, given the constant nuclear activity happening within it. This nearly perfect sphere is made up mostly of hydrogen and helium, with intense nuclear fusion reactions happening in its core. The core is where the sun's energy is born under extreme pressure and temperatures around 27 million degrees Fahrenheit. Hydrogen atoms fuse into helium, releasing vast amounts of energy in the process. This energy then travels through the sun's layers, taking thousands of years to reach the surface and finally just over 8 minutes to reach Earth after it escapes into space. Now let's talk size. The average radius of the sun is approximately 432,450 miles or 696,000 kilometers, making its diameter about 864,938 miles. That's 1,392,000 kilometers. In other words, you could fit about 109 Earths side by side across its face. And if you wanted to fill it completely with Earths, you'd need about 1 million of them. This mind-blowing fact truly puts our planet's size into perspective. The sun's surface area is so vast that even the Earth's biggest continents seem microscopic in comparison, and its circumference, which is the distance around the sun, measures about 271,346 miles or 4366813 kilometers. Just think about that. A single trip around the sun's surface would be more than 100 times the journey around our entire Earth. And yet, despite this massive size, the sun is far from the largest star we know. Take Betelgeuse for example. This red supergiant located in the Orion constellation is approximately 700 times the diameter of the sun and shines about 14,000 times brighter. If our sun were the size of a basketball, Betelgeuse would be the size of a football stadium. Its sheer scale defies the imagination and makes even our enormous sun seem small. Betelgeuse is so large that if it replaced the sun in our solar system, its outer edges would extend beyond the orbit of Jupiter, completely engulfing Mercury, Venus, Earth, Mars, and the asteroid belt. Larger stars like UY Scuti, a hypergiant that is considered one of the largest stars ever found. It's estimated to be around 1,700 times the diameter of the sun, which is almost incomprehensible in size. To put it another way, if the sun were a beach ball, UY Scuti would be a skyscraper reaching into the clouds despite their size. These stars are not always stable. Many of them are nearing the end of their lives and will eventually explode in supernovae, scattering elements across space that will one day help form new stars, planets, and possibly life. On the other end of the spectrum, we also find stars that are much smaller than the sun. Stars only 1/10 its size, yet they can still be incredibly dense and hot. Take white dwarfs, for instance. These are the remnants of stars, like our sun, that have exhausted their fuel and collapsed into a very compact object about the size of Earth, but with a mass nearly equal to the original star. So even though they're tiny compared to the sun, they're among the densest forms of matter in the universe. This diversity in star types and sizes reminds us that the sun, while powerful, is just one example in a vast range of stellar phenomena. Back to our sun, its energy output is nothing short of astonishing. Every second it emits more energy than humans have used in all of history. It produces about 386 billion megawatts of energy per second. That's enough to power our entire planet millions of times over. This energy is essential not just for warmth and light, but also for driving weather patterns, ocean currents, and photosynthesis, which forms the foundation of life on Earth. Without the sun, Earth would be a frozen, lifeless rock drifting through space. Its influence is so critical that even slight changes in its activity can have major impacts on our climate over time. And did you know that the sun is not a static object? It rotates, but not like a solid sphere. Its equator rotates once every 24 to 25 days, while the poles rotate more slowly, taking about 35 days. This differential rotation causes twisting and tangling of the magnetic field lines, which results in sunspots, solar flares, and coronal mass ejections. These solar storms can shoot billions of tons of plasma into space, and if directed at Earth, they can disrupt satellites, power grids, and communication systems, though they also create stunning auroras near the polar regions. In addition, the sun is slowly but surely changing over time. It's currently about 4.6 billion years old and is believed to be in the middle of its life cycle. Eventually, it will exhaust its hydrogen fuel and expand into a red giant, engulfing the inner planets, possibly even Earth. Then, after shedding its outer layers, it will shrink down into a white dwarf and cool over billions of years. While this might sound dramatic, it won't happen for another 5 billion years. So we have plenty of time to appreciate the sun's warmth and brilliance. Astronomers study the sun closely, not only because it's our local star, but also because it offers valuable insight into the workings of stars throughout the universe. Every discovery made about the sun helps us understand more about the life and death of stars, stellar evolution, and even the origins of galaxies. Modern instruments like the Solar and Heliospheric Observatory and the Parker Solar Probe have brought us closer to the sun than ever before, revealing intricate details about solar winds, magnetic fields, and the mysterious corona, which is actually hotter than the surface itself, a mystery scientists are still trying to fully explain. One fascinating recent finding is that the sun's outer atmosphere, known as the corona, can reach temperatures of millions of degrees Fahrenheit, far hotter than the surface below. Scientists believe this extreme heat may be due to tiny magnetic waves or explosive bursts of energy that continuously transfer heat upward. This paradox challenges much of what we thought we knew about stellar physics and opens the door to exciting new theories and exploration missions in the near future. The sun also emits a constant stream of charged particles known as the solar wind, which extends well beyond the orbit of Pluto. This stream creates the heliosphere, a massive bubble-like region that protects our solar system from harmful cosmic radiation from interstellar space. Without this shield, life on Earth could be at greater risk from the high-energy particles that fill the galaxy. Yet another reason the sun is vital to our existence in more ways than one, and it's not just about heat and light, but about protection, stability, and the delicate balance that makes life possible. So while the sun might be just a medium-sized star in the grand scheme of things, to us it is everything: a source of life, warmth, energy, and cosmic wonder. Its immense power and complexity continue to amaze scientists and inspire people around the world. And the more we study it, the more we realize how deeply connected we are to the vast cosmos above.